So today we are going to start our new subject named industrial instrumentation. In industrial instrumentation we will discuss about the temperature measurement. We will discuss in industrial instrumentation roughly we will discuss about the temperature measurement, which is giving module 1. Second, we will discuss about the second pressure measurement. Then we will discuss about the level measurement, different type of measurement, process parameter, pressure level measurement, and other parameters. So many different parameters we will discuss in the industrial instrumentation. Pressure, temperature, level, and flow measurement we will also discuss. In main topics in this industrial instrumentation measurement we will discuss. So today we will start from our topic name is temperature measurement. For temperature measurements we can use the RTD. In our first lecture we have discussed about some introductions module. We have discussed about the basic functions of RTD, and here we will discuss how RTD used and what type of connections they can use to measure the temperature in industrial instrumentation. So RTD, this is the look RTD. This is a practical diagram. This RTD look like this. This portion is contact with the temperature who's to be measured. And here connection part are 2 or 3 or different type of connections on figure here. And within this rod, the RTD sensing element are put it. In this, we can say that. So introduction, we see the introduction. The resistance temperature detectors are sensors that measure the temperature by correlating the resistance of RTD element with temperatures. The most common RTD is PT100 and its resistance 100 ohm and its increased temperatures. Means the simple means this RTD, and this RTD dipped inside the temperatures, you touch with the temperatures, its resistance start to increasing. Based on that model, if temperature increase, then resistance increases. If the temperature decrease, then resistance decreases. Generally, we can give the measurement equation RT. The RT equal to R0 into 1 plus alpha delta T. This is the alpha delta T. This is the R0. So using this equation, if temperature increases, then the resistance is increased. If the temperature, this is the actually not the, this is the exact equation. This is the linearized form of, for making a measurement linear. So this is a linearized form of equations for industrial instrumentation. So this is the most common RTD PT100 that 100, and this is the how does it work. This equation given. The RTD operate on the principle of metallic resistance increases with increase the temperatures. The resistance of temperature relation given by this. Then RT equal to, this is the resistance, this is the resistance at T degree temperatures. This is the resistance at T degree temperature. This is the resistance. RT is the resistance at T degree temperatures. RT is the resistance at T degree temperatures. Where R0 is the resistance at 0 degree Celsius and alpha is the temperature coefficient of resistance. The applications of RTD are widely used to their high accuracy. In this way, we can. This is alpha is temperature coefficient. Alpha is a temperature coefficient. Originally, platinum, its value is for temperature coefficient alpha. For platinum, alpha is generally 0.385. This is the value of alpha. Generally, we have used the PT100. What is the means of this? Generally, we can use the PT 100. PT 100. What is the mean of using PT 100? PT 100 means the resistance, this R0, the value of R0, it will indicate the value of R0. This means value of R0 is 100. Value of R0 is 100 ohm. Means this is the value of P. This will indicate temperature at 0 degree Celsius and its resistance ohm 100. Its temperature is 0 degree Celsius. Its temperature at 0 degree Celsius. Applications of RTD. So this is the, so in this way, this is the working, how this is working. Working simple. If temperature increases, then resistance increases. The applications of RTD, where the RTD can be used and why we are studying this RTD. So first, generally this man functions to measure the temperatures, and it can be used different places to measure the temperature. Suppose that RTD are widely used due to their high accuracy. First, it's used because of their accuracy is very high. Repeatability, it is providing same output, approximated. Just its repeatability high, its stability is generally very high. Because generally for these things we use the platinum material. That's why it has compared to thermocouple and RTD. So this is the RTD. We have also discussed the linear graph of RTD. It is look like this. This is the temperatures, this is the temperature graph, this is the resistance. So RTD, generally PT resistance we use, platinum resistance. So this RTD generally use the, because of its high accuracy, 3-point repeatability and stability. Second application, industrial process control. In a process industry, for measuring this chemical industry, process or manufacturing industry, to measure the temperatures, stability. So common, generally heat exchanger to measure the temperature of boiler, RTD to measure the temperature of boilers, heat exchangers and reactors. These are the industrial processes that mainly measure the, so in a boiler and heat exchanger and reactor. Second, food and beverage industries, it's used for temperature monitoring in cooking. Suppose that any food is temperature, particular temperature required, exact temperature, therefore so that time we need to put the RTD to measure the temperature, particular temperature of particular vessels. Next, use of pasteurizations and storage. Those are ensure compliance with safety regulations. HAV, high building automation, the temperature control in air handling units, ventilation systems, and heat and energy efficiency improved. In air conditioning and building automation, generally to measure the temperatures and to measuring the temperature at particular levels, we can also use the RTD. Next, the power generation, we can also use the power monitoring of the boiler, steam lines, turbines, components, different types where we can use the RTD. Suppose that this is the steam line is going on. This is the steam is going. This is one line. This steam is going on this. So RTD put it on here. RTD put it on here. That RTD to measure the temperatures. Suppose that this is the reactor. We will see, suppose that this is the reactor, a reactor tank like this. Some heat is supplied from here and another water coming from such like this. To measure the temperature of this tank, sometimes RTD put here to measure the temperature of this steam, so that the temperature of the tank can be maintained according to our requirement. In this way, different type can be used. Pharmaceutical industries, temperature monitoring, drug manufacturing. For because for making any particular drug, we need to exact temperature and pressures. For measuring that temperatures, we need to RTD to make storage and installation. These are used laboratory equipment like in cubes. Next is automotive or air storage. This is section automotive. Engines and exhaust temperature monitoring we can use. Next we can use precise fuel and emissions control. So this is a generally applications where we can use. So generally the question will ask the applications of RTD. Write the 5 or 10 applications of RTD. So you have to write all these applications. Next topic we will discuss the industrial construction requirement. For construction RTD, what is the requirement? For industrial use, the RTD must be robust, reliable, and resistant to the harsh environment. So some key including this RTD. First, making a RTD, what is the things are required? Suppose this is the RTD. So first we need the primary thing, the sensing element who can sense the temperatures, and according to sensing temperature, it can change in resistance. So first we need to sensing element. So which element can be used for sensing? First PT100. PT100 PT100 element can be used. PT100 means its resistance is 100 ohm at 0 degree temperatures. PT100 means its resistance of PT500 means its resistance is 500 ohm at 0 degree Celsius temperature. PT1000 means its resistance is thousands ohm at 0 degree temperature. The most stable and accurate. Second, sensing element, because we need the platinum. Why? Because it is the most stable and accurate, because it has more linearity. So many things that we are getting our requirement from the RTD. Next, the second priority we can give the copper and nickel, use in specific application, but have limited ranges, because why range is limited? Because its output is not much linear. Some like this move like this, some move like this, but this is the like platinum. PT is like this is the platinum. Suppose that this is the copper and this is the nickel. Nickel has more sensitivity than compared to PT, but it shows the more non-linear behavior. No, that's why we can't use the generally nickel and copper, and that's why these two are non-linear and make them limited uses. Second, RTD connection. We see the different type of connections. Second is the RTD requirement, which is the connection of RTD. Second, we fill the connection of RTD. We have it is not here. 2.1 point will be there. That's the name will be connection of RTD. How will connect the RTD to get the maximum output? Connection. We can say that this is the connection. If we want to get maximum output, so this is the RT 2-wire connection. First we prefer 2-wire connection. 4-wire. How the 2-wire connection is this? Suppose that this is the RTD. This is the RTD. One wire is here for this name and another wire for right. So this is the this can be for grounded and this can be for supply. Simple connection to do 2-wire, and 4-wire is there. One for this is the 2-wire connection is provided here, and this is the example of 3-wire connection. It will look like this: 4-wire connection, 3-wire connection, 2-wire connections. So what are the limitation and uses and benefits of 2-wire, 3-wire connections? Why can be used? 2-wire RTD simplest but less accurate due to lead resistance, because here lead resistance affect this accuracy. Simplest है, but because of lead resistance aid the on the meter reading, that's why this less accurate. When we do not need to more accuracy and we want to less cost, that time we need to do RTD, simple and less accurate, because lead resistance. Why the less accurate? Because lead resistance aid to measurement. Next is a 3 wire. Most commonly used industrial applications for compensative lead resistance, because it improves the accuracy. The 3 wires improve the accuracy than compared to 2 wire, because the lead effect will not aid on resistance measurement. It will compensate each other by measuring resistance. That's why it improves the accuracy and the cost is not more high. So moderate, when moderate accuracy and cost is low, that time we can use the 3 wire connections. And where the accuracy is not concerned, that time we can use the 2 wire resistance. Fourth is a 4 wire RTD, provided highest accuracy by completely eliminating the lead resistance effect. Provide highest accuracy by eliminating the lead resistance effect. Whenever we want to more and more accurate resistance, but even cost is very high. That time you can use the 4 wire resistance. That is the highest accuracy. This is the highest accuracy by compared to other, and it eliminates the lead resistance effect. That's why in this way we can provide 3 type of connection in RTD: 2 wire, 3 wire, and 4 wire based on our requirement. Second construction of RTD is the thin film. This is the classification based on the question. This is in other region based on the constructions. This is the thin film RTD. The thin film RTD elements consist of a thin metal. This is the thin metal deposited on ceramic substance. Here we can see this outer is ceramic substance. This is resistance trimming loop, and this is the ceramic substance. This is the ceramic substance. Ceramic substance. This is ceramic substance. This is the lead connection for giving connection to RTD, for giving to that output to modify or amplify next level for signal conditioning. That time, this is the resistance trimming loop, and this is the material. That's suppose that this PET material is this. That pattern, resistance pattern shown like this. So thin film RTD sensor are known for whenever durability and reliability is required, then we can go the resistance and variations. Next is the classification constructions requirement of protective sheet in, because we need to protection sheet. Sometimes temperature are too much high. Because of that temperatures, if they put direct contact with process temperatures, so it may be the platinum RTD may be melt. So that time we need to protection sheet. How the protection sheet is nothing but, suppose this is the RTD element. RTD element look like this. Outer the RTD element, we need to set like protections, so that this protection sheet can contact with the high temperature. Based after that, this RTD element can sense the heat and change the resistance. Based on it, we need to protection sheet. We can see. So which material protection sheet we can use? We can use the stainless steel 364. Two materials. This is the name of stainless steel. 316 and 304 are used to corrosion resistance. Sometimes there are so many industries where if we can direct put the RTD within the corrosion materials, it can react. The platinum can react and its output may be changed. That's why to outer we need to protection sheet, temperature protection, corrosion, to remove the chemical reaction, so many things. Those are inconel suitable for high temperature. If we are putting RTD on the for high temperature, man, that we can make that time. The protection's name is inconel. There's a protective sheet material we can use. Teflon coated sheet used for chemical resistance in harsh environment. Next is the insulation and wiring. The ceramic and glass insulation used for high temperature applications. F, P, T, and C insulation provided resistance to moisture and chemicals. Hence, insulation resistance is also provided to ceramic and glasses insulation used for high temperature applications, and PET insulation provided for resistance moisture chemicals. For which type of element has more response time, we need to less and less response time so that we can get easily output. So thin film, whenever we need to fast response, then we can use the thin film RTD connection for fast response. Wire bonded 2 wire 3 wire one highest accuracy but slowest response. Connection, we have the construction, we have discussed two type of construction. First type we have discussed based on the wire like 2 wire, 3 wire, 3 wire, and 4 wire. In whenever we need to high accuracy and less slower time response, then we can use the 2 wire, 3 wire, and 4 wire RTD and a selection of 2 wire, 3 wire based on their cost and accuracy. Second one, we need to high fast response. That time we use the thin film RTD. Based on the response, we can decide it on this. Next, the temperature ranges. So standard RTD generally the range is minus 200 degree to 850 degree Celsius. Industrial RTD are designed minus 50, but industrial because of after the 600 it may not be accurate and probably stability may be affected after the 600. That's why generally industrial we can use the minus 50 to 600 degrees Celsius. That's why it gives the very good output. Second things, environment protections. Explosion proof designing for hazardous areas. So waterproof, dust proof enclosure for outdoor applications. We can use this. So this is the requirement of RTD we have discussed on last class being concerned. These are industrial construction of RTD. We can discuss first is RTD sensing elements. So generally be platinum 100 thousands and 500 based on the requirement. Sometimes we can use a copper or nickel per second based on the connection. This is the based on 2 wire 3 wire. Based on this we can use 2 wire 3 wire, or it maybe we can use the thin film RTD. Based on the applications we can decide it. Then we can use a protective sheet and insulating wiring. And last is a response time. Based on response time we can select which type of RTD we will have to prefer. It may be thin film or based on the wire. Temperature range, general temperature range we can say minus 200 degree to 850, but in industrial application we can design for minus 50 to 650, minus 50 to 600. So generally if you go for any interview they will ask you what is the RTD temperature ranges. If you tell minus 50, so they will next question they will ask, it can be used 850 for industrial measurements. So that time you can, so for generally industry measurement we can use minus 50 to 600, because if I be using up to, it may be, its linearity may be affected, its stability may be affected. So that's why we choose this optimum ranges for industrial environment. This environmental protection is also the exploration proof design for hazardous areas, waterproof and dust proof enclosure for out applications. Next our topic is a RTD transmitter. We have discussed the RTD. So why we need RTD transmitter? First question we asked, why we need RTD? Why we need a transmitter with RTD? This means is a RTD plus transmitter. RTD transmitter का मतलब RTD means RTD plus transmitter. So why we need the RTD. Purpose RTD transmitter to convert the resistance signal from the RTD into a standard output such 4 to 20 milliamps. HRT mode bus, Profibus for easy integration with control room. And until we have discussed the RTD, right now this RTD we are discussing with transmitters. Suppose that any RTD is giving temperatures. Suppose that RTD measure the temperatures, temperature T, and it convert the output. That we cannot transmit that output resistance to control room directly because we are not able to transfer the resistance from one places, and if it is a transfer then so many errors and can be occur. So that's why we need to change this R into transferable form. So how we can transmit? First, generally normal industry 4 to 20 milli signal is transmitted, milliampere volt signal is transmitted, because there's so many region, because this is the losses is very less. Or nowadays industries are using HART, but for transmission. So H at high addressable remote transducers. That's the full form is high addressable remote transducers for transmitting. And nowadays wireless communication we can use for transmitting this signal using by the Modbus and Profibus for it. So this is our special topic in advanced industrial instrumentation we get. This is the new technology, the technology used to wireless technology for transmitter. So why the purpose of transmitter? To transmit the converted resistance into signal, standard output. This is 4 to 20 milli. That output may be 4 to 20 millimeter. H and high addressable mode bus for easy integration to control. So then until, because here we are measuring on temperature on the field. That field output we have to send the control room. That's why transmitter picture will come. So different connections we have already discussed. We can see how the transmitter connection like looks. So suppose this is a two RTD, two LRTD. Then these two are provided to the transmitter. The transmitter amplify, modify, and remove the error and convert it to 4 milliampere signals and corrected output so that Modbus, Heart, and Profibus can transmit the signal to the control room. Now, mainly the part of transmitting the signal, transmitters means transmit the signals from field to control room. This is the 2 wires, 3 wire control room. This connection look like this. This is the RTD and 2 wires connection. 3 wires connection look like this. The 4 wires connections. This is the 4 wire connection like this. 4 wire connection we can provide like this, but this cannot be preferred. Cannot be prepared compensating loop. That's why the 4 wire not prepared for compensation. So that's why we use generally this preferred, having a paired lead to each other. So based on we have discussed about how we are providing the connections to that system. So this is the transmitter purpose RTD. Transmitter to convert resistance signal from a RTD to into a standard output 4 to 20 milliampere Modbus, Profibus. For easy integration with control rooms, RTD look like this. Next we will discuss the type of RTD. What is the type of and how the RTD type of RTD? First is the headed mounted transmitter RTD. Its head is mounted, installed in the installed sensor head for compact and field ready to applications. DIN rail mounted RTD used for control panel, centralized temperature monitoring. Centralized temperature monitoring, that's planning. Field mounted RTD, their housing is rugged enclosure to use harass environment. So different type of connection and which connection we can use the RTD. Next, we will discuss about the feature of RTD. What are the feature of RTD transmitter? Why? Because generally we have RTD already there. So why we are making the RTD transmitter? First, to get linearization, to convert the non-linear RTD signals into proportional output. Suppose that any non-linear behavior come for transmitter, this R is coming, supported R, then we have to change this R into 4 to 20 milliampere. So photon. That's why for linearized output range we have fixed. It may be 4 milliampere or it may be 20 milliamperes. Generally, some interview they will ask you why we are not selecting 0 to 20 milliampere? Why we are selecting the 4 to 20 milliampere? Can you tell me in the regions? So generally, why we are not selecting 0 milliampere? Because if any wire or connection is break, then it will if the lower value is selected 0, so the connection is missed, it always give the 0 reading, then we cannot identify wire is broken or any connection is broken. That's why we are not using the 0 to 20 milliampere. That's why we need to, if the connection is breaking, that time it will show 0 degree Celsius. Otherwise, if any lower value reading will come, then it will show the 4 milliampere. So first linearization to convert the non-linear output into linear into proportional to output signals. Temperature compensation minimize the error to environment. Temperature transmitter may be compensate the error to the environmental variations. Next is electrical isolation to prevent the signal interference in industrial environment. Next is the digital communication. Digital communication HART, Profibus, Modbus, enable to monitors and calibrations. HART, Profibus, Modbus, enable remote transducers. So in this way, we have discussed the transmitters in three parameters in RTD. Next, we will discuss about the thermistors. Second, our topic for industrial measurement in for temperature measuring. But this all the instruments we have discussed in briefly when we are discussing different type of instrument, and also in transducers we have already discussed the thermistors principal operations. Again we will discuss principal operations and how they are using for temperature measurement. Here we will discuss in the industrial measurement. First, the principal operation of thermistor. Thermistor is thermal resistors, a type of temperature sensor that exists cause significant changes in resistance with variation in temperatures. When we are changing the temperatures, then its resistance again will changes, but its will not change linearly. Its resistance change non-linearly. That's when in case of RTD, the resistance is changing linearly. This resistance is not changed linearly. This generally in thermistor we will talk about the NTC. This NTC look like this. In transducers we have discussed two type of thermistors. First is a PTC, positive temperature resistance. Second is an NTC. In PTC we have also discussed two type of polysters, which resistance increases with temperatures, and another which initially if resistance decreases and sudden critical point is its resistance start to sudden increasing. So in this, so that things we all know, we are not required. Here we will discuss industry how to measure the temperatures using these thermistors, and using this thermistor how we can make a transmitter, because we are not Discussion internally about the thermistors. Sorry, thermistor. So the principle of prohibition, a thermistor, thermal resistance type of temperature sensors that exist a significant changes in the resistance with variation in temperatures. The relation between the resistance and temperatures is typically non-linear. We have discussed about the this is also an NTC term is this y-axis is shown the resistance, y-axis it is the resistance, and x-axis shown is the temperatures. This is the temperatures. So in this way, it is if the we are increasing the temperature, then its resistance start to decreasing. Type of thermistor based on the resistance behavior NTPC, negative temperature coefficient resistor, that resistance decreases with increase the temperatures. We have seen the graph. Next we will discuss about the PTC, positive temperature coefficient, resistance increases with increase the temperatures. Uh, this is the PTC. PTC is generally two types of. Uh, this is the behavior. Initially resistance start to decrease. After the Curie point, it resistance start to suddenly increase. This NTPC generally resistance increase and temperature increase, then resistance will decrease. The basic working mechanism. The resistance of thermistors is determined by the material composition, usually metal oxide. Next, change in the resistance is follow the Stiffness-Hart equation exponentially functions. So sensor generally the equations resistance, how the resistance of this thermistor changes, we will discuss. I think it is not right now. I can write RT equal to R0, if it may be not written on, into e to the power beta is a material constant, beta upon 1 by T into 1 upon T0, this T0. RT is a resistance at temperature T degree. At this temperature, resistance of this R0 is resistance at 0 degree temperature. This is the T0. What is the value we have put at T0? Beta is called a material constant. It is decided based on which type of materials we have used based on this. In this way, resistance are exponentially decreasing. According to this equation, resistance of this will changes. So different type of sensors we can use. Suppose the thermistor sensors. First is a rod sensors. Second is a bead thermistors. And another design is a Dix thermistor. And one is a thermistor of circuit symbol. So classification of thermistors we will see. Bead thermistor. Bead thermistors we have seen. This is the bead thermistor. This is the bead thermistors. We can see from here. Bead thermistors means made for small bead or metals, oxide, encapsulated in glass, used in medical and precision applications. Very precise temperature measurement. That time we can use this resistance. Dix and chip operator. This is the Dix. Sometimes this is the called Dix. Look like this. Dix temperatures. The larger or flat rectangular shape is there, and this common industrial power application. Generally more industrial it used for in power application we can use also this. Next is rod. Rod is rod applications. This rod look like this. This is the diagram of rod applications. We can see that from here. Rod applications. The cylindrical shape with high durability. Suppose that this is the rod like this is the rod like this, This is the rod like this. This is the rod like this. This is the rod like this. This is the rod connection like this. Cylindrical shape with high durability used in HAV or automotive systems. Surface mount thermistor, compact and designed for PCB mounting, used in electronic circuit for temperature compensations. Surface mounted. So this is surface mounted connection also. The different type of thermistors that we have used. Next, the temperature measuring. The circuit, how the temperature circuit. This is the how this is temperature measurement using. So this is the this is the power supply battery. This is the power supply. This current is flowing. This is a thermistor. If the resistance will changes, then its resistance will changes. Then this current will change. This current, if it is exported anywhere, the temperature, if temperature changes, means indirectly its current is changing, because temperature changes, resistance changes. If the resistance changes, this loop current will change. The thermistor are widely used for accurate temperature measurement due to their sensitivity. First, measurement process. A thermistor is placed in environment where temperature need to be measured. A small current is is passed through the thermistors. The voltage drop across the thermistor is measured. Using the pre-calibrated resistance temperature curve for mathematical formulas, temperature is determined. How the temperature? First, measurement process. A thermistor placed environment. This thermistor is placed in the temperature measurement environment. This thermistor is placed in temperature measurement environment where we need to measure the temperatures. Second, a small current pass through the thermistor. This is the small current. This is a small current pass through the thermistors. So the voltage drop across the thermistor is measured. We can also measure the voltage drop across in this thermistor. Voltage drop across in the thermistor. Using the pre-calibrated resistance temperature curve or mathematical formula, we can measure the we can determine the temperatures. Now, thermocouple operations. Next class we will discuss about the thermocouples.